So those ones are from Unit 1. And then 3 says the probability that the vowels are together. The vowels are together. And it's probability. So what do we do when it's probability? Whatever comes after the word probability affects the top. So we use the word probability. The vowels are together. How many vowels are together? 840 different ways, right? Then for probability, we always go over total no restrictions. And what's the total no restrictions? This one, right? Which is this number. So I'm going to divide by 34,650. And then it says to the nearest hundredth percent. So I have to times by 100. And you get 2.42%. Okay? So that's using chapter 1, which was probability, or it was not, firms and comms. And then chapter 3, probability of firms and comms. Okay? The next thing we're going to do is this one. So we have 40 people surveyed, 20 liked ice cream, 23 liked chips, 3 liked neither. How many people liked ice cream only? That's A. And then B is determine the probability a person liked ice cream and chips to the nearest hundredth. So this is chapter 2, set theory, Venn diagrams. This is chapter 3 with set theory. So try them out. Number 4, I gave you the number of people. I gave you the number who liked each, and I gave you the number who liked neither. So if I give you that information, you can find the and, right? As long as I give you all that info. So if I take the 20 people who liked ice cream, and I add to it the 23 people who liked chips, and I add to it the 3 who liked neither, so those are all the separate ballots that got put in, that's 46 ballots. However, there are only 40 people. So we subtract, and that gives us 6 in the middle. So we have ice cream and chips. And we have 6. And then for ice cream, we have 14 only. For chips, we have 17 only. And then here we have 3. So how many people liked ice cream only? 14. Then this one says, determine the probability a person liked ice cream and chips. So that's 6. But because it says probability, it's 6 out of total, which is? 40. And what is that to the nearest hundredth, not percent? Sorry? Yeah. So remember with probabilities, we really have to look and see, do they ask for percents? Do they ask for just decimals? Okay, this one's amazing. The probability I win the lottery is 5 out of 8. Wouldn't it be beautiful? I'd even give you guys something. Yeah, like a pet. Maybe a fish, each of you. A. No, like each of you, a fish. Yeah, well, if I win the lottery, you can each get a fish. I can splurge. Okay. It'll be a beta fish, but you know, still a fish. It doesn't, like, it's not less of a fish than a goldfish. It's a fish. It can live in small areas. It's not supposed to, but it can. Odds in favor. Have you seen people put beta fish in really tiny places? They can't move. It's like totally mean and nasty. You know what I mean? Fighting fish.
Yeah, they're like, little things are like that.
They can be in tiny, but like, don't you think they want to be in a little bit bigger? I would say so. So, they should be. So A, odds in favor of me winning. B, odds against me winning. This should be fast. Okay, we have odds in favor of winning. Whatever comes after favor comes first. So it's going to be winning to not winning. And these add up to total, right? So these should add up to 8. Because 8 at the bottom of your probability is total. And this is win, because it's probability of winning. Winning over total, right? So odds in favor of winning, this will be 5. And how many times would I not win? 3. Now if it says odds against winning, whatever comes after it comes second. So winning would be second, not winning would be first, and it would flip 3 to 5. Simplify. When you're adding or subtracting rationals, does your denominator go away? No. Your denominator only goes away when you're solving, when there's an equal sign in between.
What?
So, can we get any common denominators for these ones? Like, can we make them be each other at all? We can't make them be each other, so we have to multiply them by each other. Turn around, Sid. So we get y minus 3, 2y plus 5. So we get an equal sign, and we distribute. We get 4y minus 12. Do we distribute our denominators? No. Do we get rid of our denominators? No. We get common denominators loud and proud, and we keep them. That's what we do. Minus, distributing a 1 in does nothing, so I get 2y plus 5 over 2y plus 5, y minus 3. Now I have the same denominator, so I can write them all over 1, not getting rid of it because it's not solving. On the top I get 4y minus 12, and then I have to remember to distribute, minus 2y minus 5. So I get 4y minus 2y is 2y. Negative 12 minus 5 is minus 17 over 2y plus 5, y minus 3. Y cannot equal negative 5 halves or 3. Okay. One more. And we're going on to degree 2 functions.
No. Monday.
Okay. Solve. When I say solve, hello, I'm up here teaching. Don't know if you know this, I'm the teacher. I'm up here teaching. Okay. So, when we solve, do we get rid of the denominators or not?
Mm-hmm.
Yeah, we do. So, this is the only time you get rid of the denominators. We have 3 over x plus 1 equals 2x minus 3 over x minus 1. So, you have to multiply, because the first thing you need to do when it's solving or adding and subtracting is get common denominators. So you're going to have to multiply this one by x minus 1, x minus 1. This one by x plus 1, x plus 1. So I distribute the top, I get 3x minus 3. And the denominator is x plus 1, x minus 1. Equals, need to FOIL, 2x squared plus 2x minus 3x minus 3 x plus 1 x minus 1. And so we get same denominator, so we can just say numerator must equal numerator. So 3x minus 3 equals 2x squared minus x minus 3. These two get together. Now, you have to remember that you only get rid of the denominators because the denominator is equal, so then you can say that the numerator is equal, right? That's the only reason why you're getting rid of them. That's why we don't get rid of them with addition and subtraction. There's no solving happening. There's no equal sign. The reason why these ones go away is because if this denominator equals this denominator, then this numerator equals that numerator. Subtract 3x, add 3. You have to get it to one side when it's a squared. And so I get 0 equals 2x squared minus 1x minus 3x is minus 4x. And the 3's cancel. So I can just add a 0 to the back for my c. So my a is 2, my b is negative 4, my c is equal to 0. So x equals 4, it's minus a minus, negative 4 squared, minus 4 times 2 times 0, all over 2 times 2. So x equals 4 plus or minus root 16 over 4. X equals 4 plus or minus 4 over 4. So x equals 4 plus 4 over 4. Splits. X equals 4 minus 4 over 4, which is 8 over 4 or 2, which is 0 over 4 or 0. So x equals 2 and 0. Now, what do we have to make sure we do? State our non-permissible values behind it, which is 1 and negative 1. Because we have to check and see if any of them are extraneous, right? Right. So, going over polynomials. If I gave you that as my graph, what degree is it? Yeah, degree 1. It's a degree 1 because it discos. It's a degree 1 because it's a straight line. Right? Now, that means that if it's degree 1, it's y equals ax plus b, where x would be to the power of 1, making it a degree 1. Now, what would a be in this case? Would a be greater than 0 or less than 0 in this case? Why? You're right, but why? It ends up on the right. So a is greater than 0. A is positive. Our leading coefficient is positive solely due to it ending up on the right. Correct? Now our b value, everyone has phones out, better put them away. Our b value is linked to our what? Our y-intercept. And our y-intercept in this case, is it greater than 0 or less? It's greater because it's above the x-axis. So b is also greater than 0. Right? What's my domain for this one? And my range for this one? XER and YER because discoing, right? Unless it's a word problem. So my domain is x such that x is an element of the reals. And my range is y such that y is an element of the reals. Okay? What if I give you this type of function? What degree is this one? It's a degree 3. It has to be an odd degree because the arrows are in opposite directions, right? It's still discoing, it just has some bumps going on in the middle. So it's still an odd degree if arrows are in opposite directions. So I have y equals ax cubed plus bx squared plus cx plus d. Is my a greater than or less than 0? Why? Yeah, ends down on the left, on the right. You're non-writing hand. So a is less than 0 because it ends down on the right. We also know it ends up on the left because they have to be in opposite directions because they're odd. What about d? Is it greater or less? It's greater because my y-intercept is actually above the x-axis. And what would my domain and range be for this one? It's XER and YER because why? It's discoing, right? He's just doing a little flop in the middle, but his arms are still discoing in the end. So if the arms are discoing in the end, if I put a person on here, his arms are still discoing, he's just doing a little wave in the middle. It's still, as a word problem, x such that x is an element of the reals, and y such that y is an element of the reals. Today we're going to look at quadratics, which we've looked at before. In either class you were in grade 11, it doesn't matter what class you were in, you did quadratics. So we're going to go to our notes, please. So on page 3, we're dealing with actual quadratic equations. They're degree 2 because the largest exponent is 2. We know from last year that they're either concave up or concave down, which means their arrows are always in the same direction. So odd degree functions, arrows are in opposite directions. Same degree or even degree functions, even have arrows in the same direction. Okay? So your leading coefficient still tells you how it ends on the right, but an even degree just makes it end in the same direction on the left, as opposed to the opposite, which degree 1 and degree 3, which were odd functions, did. The other thing you need to know is because the arrows are in opposite directions, what are the number, or so in the same direction, what are the number of possible x-intercepts? What's the maximum always? Maximum equals the degree. What's the degree? 2. What's the minimum on these ones? 0. Why is it 0, Jeff?
It can just not touch the x-axis at all.
Yeah, it can just not touch it. It can either be completely below the x-axis because the arrow's in the same direction, or completely above the x-axis because the arrow's in the same direction, right? So it could look like this. And you'd have no x-intercept. And then you always have the same, you can have a 1 as well. How do you have a 1? Well, that's where you have it. It comes down, just touches the x-axis, and it goes back up. So you have 2 x-intercepts there. They just have to be the same 1. So it's 1 x-intercept. Okay? So we're going to do 1 together. Y equals negative 3x squared plus 2x plus 1. I want you to type it into your calculator and graph it. Okay. So I know that this graph has a y-intercept at 1 at the very least, right? So I know it has one at 0, 1 at the very least. Now, from all the rest of the graphs, we could just pull stuff off of them, right? But if we needed a max or min, even on a cubic, so on a degree 3, we had to find it using our calculator, right? Which was nice. They didn't make us figure it out any other way through calculus. So this one we know, because it's a negative leading coefficient, we know it's down on the right. We also know then it's down on the left as well, correct? So we know that this graph is going to be a maximum. No matter what, we know we should be looking for a maximum, right? How do we find the maximum on our calculators? We did this on Friday. Second, trace, maximum. You need to be on the left side of it, enter. You need to be on the right side of it, enter, enter. Now don't overthink it. Don't try and be like 8 years left of it. Just be like a little left, enter, a little right, enter, boom. You know, you don't need to hold it down for 27 years and see what's going to happen. Okay? So you get 0.3333 and 1.33333. So it's somewhere here. And I'm going to label it myself because I want to teach you something. So this looks like it could probably turn to a fraction, right? Because they're repeating decimals. And repeating decimals can turn to fractions. Everyone following me? Did everyone find the maximum? Because if not, you can't follow me. Everyone have the maximum found, second trace max, left bound, right bound, enter. You have it on your screen. Okay, now what you're going to do is you're going to go second mode. That gets you out of it. Second mode. And now you're just on the basic screen again, right? Your main screen. You're going to go X. You can leave it open now, Jackson. Those people are gone. X math. You can just leave it open, Caitlin. X math. Enter, enter. And they'll turn whatever x you had there. Does it turn it into a fraction? No, it didn't with mine. So it actually isn't a repeating 0.3333333. It's 0.33333366603. So I have to leave it as a decimal. Let's check if my y is. Because I can check if I can turn my y into max 2. I go alpha, number 1, and it brings up the y. and then I go math, enter, enter. And it did turn that one. Mine turned to 4/3. Did yours? Okay. So I'm going to go 0.33 and 4/3. Alpha 1, math, enter, enter. So you can check and see if they turn to fractions, okay? Yeah, it would be more helpful because when you go to do your range, you're going to need that 4/3 instead of 1.33 because 1.33 isn't 4/3, right? Okay, so my rest of my graph, if I want to get the rest, I can just go second, graph, and it gives me a table of values. And I want to pull some off of there. So 0, 1, 1, 0, 2 and -7. And I'm going to go upwards, -1 and 4. -1, -4, Crystal, not 4. Yeah. So it looks something like that. So I'm going to have to find the maximum myself, right, using my calculator. But then I can pull points off of my calculator for the rest. Now, what's the leading coefficient in this case? -3. Just the number that's in front. What's my y-intercept at? 0, 1. What's my number of x-intercepts? 2. What's my domain? What's my range? Yes. Y such that y is less than, and it's equal to because I literally found it, right? So it's not just less than. It is less than because it's the highest it can be, but it's also equal to because it exists there. Y-er. And then I have a maximum at 0.33 and 4/3. Yeah.
So when it says like less than or equal to, when would it not be like equal to? Like aren't they always on like a point?
It won't be equal to when we get to our next unit when we do exponentials and logs because it's actually just greater than or less than the asymptote, and the asymptote doesn't exist. It's a line that doesn't exist. So we'd say greater than. Right.
So like all these, they're mostly all these.
These ones will be, yeah.
Okay.
Yeah. Okay. So I want you guys to flip ahead to here. E, F, G, and H. We're going to look at E first. So E is a quadratic where A is greater than 0 and C is greater than 0, and we're supposed to sketch a graph of it. So if A is greater than 0, that's this variable. What does that tell me about the graph? If this is positive, A is greater than 0, it's positive. It's up on the right, and because it's degree 2, it's actually up on the left. And then this C is greater than 0 tells me that C is positive, right? So we know we have a quadratic that has 2 arrows up, which means it has a minimum, and it has to have a positive y-intercept. So I'm going to go like that. Could you have cut through the x-axis? Could you? Does it say there's no x-intercepts or anything? No, you could have cut through it. You could have went like that. All that matters is I have to have up arrows and a positive y-intercept, right? You're going to do F, G, and H. So for F, I know A is greater than 0, which is my leading coefficient, so that tells me it's positive. So it's up on right, up on left, and I have a negative y-intercept. So I could go like this, something like that. I need to cross the negative through the y-intercept. I need to have 2 positive arms. And please don't draw something like this. That isn't a parabola. I don't know what that is, but it's for sure not a parabola. Parabolas are symmetrical. So it still has to look like a parabola. This one here, A is less than 0. So it's down on right, down on left. And C is less than 0, so I need to have a negative y-intercept. So the whole thing could be below, right? Or you could have went like that. Ooh, that's not true. That's a bold-headed lie. So sorry. You could have went like that. That's better. And then for H, A has to be less than 0, so I have to be down on right, down on left. And Z has to be positive. Something like that. Okay? And I have some homework for you. Don't gasp or sigh.
That's amazing, thank you.
Yes, you're welcome. On top of it today. Ain't no stopping you now. Just rocking it. Okay, so these are the ones you're doing. Circle them. 1, B, and F. Roll ahead a couple pages and look for it. You didn't do B and F, did you? You did A, C, D, and E. Well, good for you. That's awesome. That means you're ahead of the game. Well, then you're not. Go back and try it again. And then 7 and 8. And for the sighers and gaspers, 9, new stuff, textbook questions.
I love homework.